So, hi everyone. So, today we'll discuss about how JavaScript engine works. How is JavaScript run inside a JavaScript engine? So, we'll talk about some internal working and architecture of the JavaScript engine. Okay. So, first of all, JavaScript is based upon ECMAScript. What is ECMAScript? ECMAScript is a standard for all the scripting languages such as JavaScript. JScript is a script language which was used to build Microsoft's Internet Explorer. And then we have ActionScript. All of these are scripting languages and they follow ECMAScript standard protocols. So ECMAScript basically defines what all syntax, semantics, and what all core features, core functionality should be present in that language, and then all the additional logic is incorporated by us to make things work. Okay, so this is JavaScript. Now, Java. Okay, so we have seen. Okay, so 99% of the websites in the world run upon JavaScript. Not only websites, 99% websites work upon JavaScript, right? Not only websites, uh, things like application programs on mobile phones. What else? Maybe CCTV cameras, robots, anything related to that. Everything can be run with the help of JavaScript. But we need to ensure some environment, some conditions. Only if only they are ensured, then JavaScript can be run anywhere. And what is that environment? That environment is JavaScript runtime environment. So what is a JavaScript runtime environment? JavaScript runtime environment is a surrounding that when given to JavaScript, uh, JavaScript can be run anywhere. So what does so every browser has its own JavaScript runtime environment. Okay. So what does JavaScript runtime environment gives us such that it can it can run JavaScript on anything, like even a mobile, torch, bulb, anything you can think of. So basically, it provides us with a JavaScript engine, all the web browser APIs, microtask queue, a task queue, event loops, and all the garbage collection, optimizations. These are all in the JavaScript engine though. But all these things, if we are provided with all these things, then these are more than enough to run JavaScript. And it's the only thing that JavaScript requires. Okay. And if this environment is present in anything, like for example in torch we might have torch apis or something like that, but if this environment is provided to us, JavaScript can be run. Okay, so this is what JavaScript runtime environment means. Okay, so yeah, so now we'll talk about how JavaScript engine executes JavaScript code. See, JavaScript engine plays a very important role in executing JavaScript code. So how does it execute? First of all, we'll try to see some examples of JavaScript engine. JavaScript engine is not a machine, first of all. Let me. JavaScript engine is not a machine. It is simple. It is simply a piece of code which enables us to run any kind of JavaScript code. Okay. So what are some of the examples of JavaScript engines? Some of the examples of JavaScript engine include V8. It is built by Google and it is open source. And till date, I think it is the fastest JavaScript engine till now. Then we have something called Spider Monkey. It is Spider monkey something. And Firefox, Mozilla Firefox has built this, and Mozilla Firefox runs on this JavaScript engine. Then Microsoft uses Chakra. Microsoft uses Chakra as its JavaScript engine. So all these companies try to make the fastest JavaScript engine, because faster is the JavaScript engine, faster will the will get executed, and faster will get the result. And like in today's in today's world, and we have so much less attention span, like all the TikToks and reels. Average attention span is maybe what 10-15 seconds. So in 10-15 seconds the engine has to compile all the code of the website and like quickly render it on the code. And whatever engine does it completes that thing in really fast, it wins the audience. So yeah, this is all about. Many engineers work in on all these things. I hope one day I also work at Google on all these things. I'm just okay. I'm sorry. Yeah. So okay. So we will talk. We are talking about how JavaScript engine executes our code. Okay. So see, we have this code over here, right? We give we have this code, and we uh, uh, like what do we do with it? We like what is the term? Okay, so we have this JavaScript code. Okay, JavaScript engine takes it, and first of all, the first thing that it does is it uh, breaks it down into tokens. What does a token mean? See, for example, if we have a line like const is equals to 5, then what would be the tokens of this? Tokens would be const a equal to and 5. So it is broken down into all these single tokens. Okay. Now after it is broken down into the tokens, so the second thing that happens is it goes through a syntax parser. Okay, it goes through syntax parser. What is the role of syntax parser? Syntax parser basically builds an abstract syntax tree of the JavaScript code. What do we mean by an abstract syntax tree? See, okay, so this is assume this is the abstract syntax tree. So what is an abstract syntax? So basically, abstract syntax tree is a data structure which is used in computer science. Basically, whenever we parse or we pass any program to generate an AST for it, AST actually removes all the syntactical sugar, and uh, in the form of a tree, it represents what's the actual logical flow of the program, what is its structure, and each node represents a while loop, a for loop, a variables, and functions declaration. So it takes away all of the syntactical sugar, and it represents what do we say, actual logical structure of the program. So let's just see it in action. It's there is a website known as astexplorer.net. I was watching Akshay Seri's Namaste JavaScript course, and it is the best on the internet. Like you can watch that literally if uh, I'm not able to explain it very nice. He is like a great person. So from his video, I got to know about this website. So in this, if we pass any function, it will show us how the AST would be formed of that function. Okay. So see, if we have this function, this would be its AST. We have all the see all this let equals to these brackets, these semicolons, these keyword functions. All these are basically just the syntax, right? But basically, what this program is doing, it is just declaring an array and just printing it. So this is the main thing, right? And this main thing is represented by AST. See, a variable declaration is there and a functional declaration is there. And if we see over here, it would just give us more details about all of that. Okay, so basically, if we take out all these syntactical structure, what is exactly left? So the two things are left: a variable declaration and a function declaration, which might get called or anything like that. Uh, I built a project in which like there are so many GitHub repositories, like so large GitHub repository, and we have to work upon them. So initially, it's pretty overwhelming to work upon all of those, right? So some so I built a RAG application in which user would put their GitHub's the repo, and my the LLM would summarize all of that and would answer any question user wants from that repo. So how was I able to do that? So initial step that I took was to build an AST first. So that after building that AST, then I proceeded to do rest of the things. But first I built AST so that my LLM would know what actually is the program doing. Like I don't want it to go into the syntax like oh it's Python, oh it's output. No, actual thing is what a function declaration is happening and function is doing some random thing. So that's it. So yeah, I went off script. You can just skip that. I just wanted to take. Uh, okay. Okay, so what does JavaScript engine does? First, we pass in our code file, source code. It breaks it down into further tokens. Then it passes it into a syntax parser, and then syntax parser builds an AS. So this was phase one. This was the initial phase. Now what happens in the next phase? In the next phase, we have two things going on hand in hand simultaneously, which is compilation and execution. Okay, so how are they happening simultaneously? Like generally, this is the flow, right? First, everything will get compiled, or if there is any error, it will be shown, and everything like that would happen, right? And then, if there is no error, then the file would get executed. This format is followed in compiled languages such as Java, C++, etc. But languages like Python or JavaScript were are interpreted languages. Initially, when JavaScript it was built as an interpreted language. Why it was built as an interpreted language? It was built because it was initially built to be used upon the browsers. So in browser, we don't have enough time to compile everything and then execute it because we want the results instantly. To get the results instantly, we have to have interpreted languages as they tend to be a little fast from the compiled languages. Okay, so that's why JavaScript was an interpreted language. But nowadays, browsers support both compilation plus interpretation. So, if both of these are supported, why don't we use both of them? So, what actually happens is whenever we pass our AST, JavaScript, builds the AST, then what happens is while the JavaScript engine interprets the language, interprets and executes it, side by side, the JavaScript engine also compiles it and optimizes the code, right? So what does the JavaScript engine does? It is interpreting and executing. But doing this, it is also it is also compiling and optimizing. these two are happening hand in hand, and these two are happening hand in hand, and all of this is happening at a single point of time, right? And what is this whole setup called? This whole setup is called just in time compilers, right? So what did I tell you? Whenever JavaScript is running upon the JavaScript engine, it is getting interpreted and executed. And during that time only, JavaScript engine is also compiling and optimizing the code, and then the optimized code is getting executed. Okay, so yeah, this is happening now. So this is happening, right? So yeah, this is how JavaScript gets executed in the JavaScript engine. This is all, I guess. Uh, yeah. So this was it. This is how JavaScript gets executed in the JavaScript engine. And oh, okay. So what kind of optimization are happening in the JavaScript code? Many kind of optimization happen, such as inline caching, um, or I don't remember. So yeah, inline caching, and have to read more about it. I forgot, I guess. Many optimizing things are going on, and also there are many optimization algorithms written for all of these things. So yeah, I should read them and make a video, I guess. Maybe. Okay, JavaScript engine also provides us with something called garbage. No, not garbage. Garbage collector. Wrong polls. I remember everything about punctuation. Okay, so JavaScript also provides us with JavaScript also provides us with something called garbage collector. What is a garbage collector? So basically, languages like C do not automatically remove the garbage, like deallocate all the variables which we have initially allocated. So we have to specifically uh, perform malloc and uh, malloc functions and all of that. C++ also does not directly provide does not provide automatic garbage collection. What it provides is something called smart pointers, etc. So yeah, but Java provides us with automatic garbage collector. So what are these garbage collectors? Garbage collectors are basically the things that it is basically what do I what would be the term for that? Okay, so basically they are like, for example, if you have a code which is a is equals to 5, then b is equals to 10, and then you over here, when you are over here on this line, these things have gone out of the scope, right? Out of the scope means we do not we do not require them now, right? If we do not require them, we should deallocate them, right? So if we are using these languages, we have to do them manually. But Java is have has an automatic garbage collection, right? So how does Java does this? Java uses something called mark and sweep algorithm, and this algorithm is also followed by JavaScript engines to automatically uh, collect the garbage, like deallocate all the memory spaces which are not in current use. So how does mark and sweep algorithm work? So then in this video, maybe I'll tell it in another, or should I tell it right now? Is it too much? Oh, I cannot decide. Okay, I'll tell it in another, okay? That would be a short one, I guess. Okay, so bye.